Alright, this is kind of the setup for the calorimeter lab. And what I'm going to do is sort of keep track of some data. It doesn't look exactly like the data table that you might have. It'll have all the same information though. This is just an example of what we've done in case you were absent for the lab and are trying to understand the concepts involved. So I'm going to show you what we have here. I have a calorimeter here. And I have balance or scale. And we keep track of some data on this whiteboard that hopefully you'll be able to pick up in the video. Now, what might not seem clear to you is actually in the lab we took the mass of the peanut or whatever it is that we're burning before we ever started. And I'll explain that when we're all done, but for now I'm just going to write down that the mass of the peanut is 0.4 grams. I'll write it in red. 0.4 grams. Okay? We'll come back to that in a little bit. Now, the calorimeter. Basically, a calorimeter is really simple. We have a thermometer. I've already put 10 grams of water in here, or 10 milliliters of water. You'll remember the formula to calculate calories is the mass of the water, 10 grams, multiplied by how much the temperature changes when you burn an item underneath of this water. Okay? So I'm going to put this back in here. So we know we have starting temperature of, and I'm going to estimate. So if you actually can pick up the actual number on here, I'm going to estimate for the sake of simplicity. Let's say we have a starting temperature of 25 degrees Celsius. Okay, next thing we're going to do is get ready to burn the peanut. Grab the peanut here, put it in here like this. And next thing I'm going to do is catch that peanut on fire and try to get the energy from the peanut to transfer to the water so that we can use that to calculate calories. So I'm going to do that right now. Okay, I got it burning. I'm already losing heat to the environment, which is not good. So I'm going to put that in here and we're going to let it burn. Let the temperature go up. So it should be right underneath the water. You're trying to get all the heat to transfer to the water. Now the peanut's going to burn for quite a while, so I'll probably stop it early, but in the real lab you let that thing burn until it was all gone. And you can see that peanut will burn a long time. Okay? In fact, the water temperature is already up to 50 degrees right there. It's already up to 65 degrees Celsius almost. Okay, I'm going to stop it at about 75 degrees. Okay, now in the real lab, like I said, we just let that burn until it stopped burning, and you still would have some peanut left. It wasn't like it totally went away. You'd have charcoal and soot left and stuff like that. Okay, so I'm going to just put that peanut down while it cools off. Okay, and we're going to write down an ending temperature of 75 degrees. So what's the change in temperature? Well, the change in temperature is 75 minus 25. It changed 50 degrees for as long as I burned the peanut. So actually, we already have enough information to calculate how many calories the water absorbed. Okay? And I'm just going to move this out of the way and move this one over. So we know that the mass of the water, because we got 10 milliliters of 10 grams of water, we know the mass of the water is 10 grams. And we got to multiply that by how much the temperature changed, and the temperature changed 50 degrees. So we'll multiply that by 50 degrees Celsius, and we would end up with 500 little calories. Okay, so we know the water absorbed 500 calories. Okay, well, the problem is 500 calories per what? Per whole peanut? No, we didn't even burn a whole peanut. Turns out in the food industry you would report it per gram. So what we want to do is we want to figure out how many calories per gram. And the way we would do that is actually that's why we took the mass of the peanut to start with. Okay? So what I'm going to do is I'm going to take the mass again of the peanut. I'm going to push this peanut on here. And now it says 0.1. 0.1 grams. Okay? So how much peanut actually burned? Looks like the difference between 0.4 and 0.1, which is equal to 0.3 grams. So the peanut burned a total of 0.3 grams. So basically, 0.3 grams of peanut had 500 calories of energy. So we could write that 500 calories for every 0.3 grams. Now if I divide those two numbers, I'll know how many calories would be in a 1 gram of peanut. So 500 divided by 0.3. And I get 1,666 calories per 1 gram of peanut. So that's how many calories in a gram of peanut. Now, unfortunately, the food industry doesn't actually report it this way. They report it in kilocalories. So to know what would be on your food package, it still says calories, but they use a capital. Capital CAL is the same thing as a kilocalorie. So if you want to know how many kilocalories that is per gram, you would divide that by 1,000. So you would end up with, in my calculations, I'm running out of room, I apologize, 1.666, we'll round that to 1.7 kilocalories per gram. 1.7 kilocalories per gram. Okay? So that's a lot lower. Actually, if you looked at a food package, you'd find that peanuts have a lot more energy than that. But that's because this is a really poorly designed calorimeter. A lot of the heat, because this is metal, goes out the metal. A lot of the heat's still probably in the test tube. We didn't give it time to absorb into the water. A lot of the heat could have been transferred, some to the desk area, some to the air around it. And anyway, I hope that gives you a good idea of what we did in the lab. You can also most likely download makeup data for the lab if you missed it online.